Hello everyone and welcome back to another video on surds. In the previous video I've covered multiplying, dividing and simplifying surds. If you haven't already watched that video, please make sure to do so as it will be a major help to understanding. It should appear somewhere in the top right corner of your screen as I am talking. So today we're going to be doing adding, subtracting and rationalizing surds. Let's get started. Okay, so adding and subtracting surds. It primarily depends if all variables have the same root number. So 1. If all variables have the same root number, then we would add or subtract only the numbers outside the surd. Now, what this basically means is if I have, for example, root 4 plus root 5, we can't just treat it as if we're multiplying where, oh, root 4 times root 5, it's just root 4 times 5, which is equal to root 20. We can't just treat it like, oh, root 4 plus 5 and that gives me root 9. No, they are considered completely different variables. It's like trying to add x and y. We don't really know what those numbers exactly are. Therefore, we can't just add them together. So the way to add or subtract surds is that all surds must have the same root number. For example, if I have 2 root 4 plus 3 root 4, we would have to add or subtract only the numbers outside the surds, in this case 2 and 3. So what this gives me is 2 plus 3 root 4, and that gives me 5 root 4, and that is my answer. If I have another example such as root 6 plus root 6, that just basically means 1 root 6 plus 1 root 6, which gives me 2 root 6. It's kind of similar how in algebra, if I have, for example, a plus a, it gives me 2a. Here, it's the exact same thing. The surd is treated as a separate variable where we can't add or subtract unless they're all the same. So, what do we do if they have different root numbers? So, if there are different root numbers, we would have to firstly break down and simplify one or more surds until all variables have the same root number, and then after that we would add or subtract the numbers outside the surd. So what this basically means, if I have, for example, root 50 plus root 32, again, I can't just consider them as the same variable and just add root 50 plus 32, and then my answer would be root 82. This is wrong because, again, they are different variables. So the way to add them would be to make sure that all of them have the same root number. So how can we do this? We can actually simplify each surd and break them down so they all have the same root number. So, simplifying surds, as explained in my previous video, we would have to break down and separate the surd into two. One, which is the root of a square number, so in this case, let's say root 25, and then another, and then make sure they multiply to give me root 50. So root 25 times root 2 turns into 5 root 2, and then for 32, I can have root 16 times root 2, and that gives me 4 root 2. And then now is when we can add or subtract them, as they both have the same variable, aka root 2. So after that, all we have to do is add or subtract the numbers outside the surd. So this just gives me 5 plus 4 root 2, and therefore my answer is 9 root 2. So let's do another example such as 3 root 200 minus 2 root 72. Now, a lot of people, they tend to do this. They just tend to do 3 minus 2 and then root 200 minus 72. Obviously, it's self-explanatory why they're wrong, because root 200 and root 72 are two different variables. Therefore, we can't just subtract them or add them together. So the way to do this would be to obviously break down each surd so they all have the same root number. So root 200 can't be split down into root 100 times root 2, and then that gives me 10 root 2. However, one thing we should not forget is the 3 over here. In the previous video, we've covered if I have, for example, x root a, what this means is it is x multiplied by whatever number root a is. So here I have 3 multiplied by root 200. Since I've broken down root 200 into 10 root 2 over here, we'd have to multiply 10 root 2 times 3. And we'd only multiply the numbers outside. We would genuinely just forget this root. So it would just be 10 times 3 root 2. So that would give me 30 root 2. Therefore, 3 root 200. We'd have to break down root 200 and then times the number outside by 3. So I have 30 root 2 minus, now we have to break down the root 72. Root 72 can be broken down into root 36 times root 2, which gives me 6 root 2, and then we'd have to multiply this 6 by 2 over here, because remember, we can't just forget it. So 6 times 2 gives me 12, therefore it would turn into 12 root 2. Now is when we can add or subtract, because they have the same variable, aka root 2. So this just equals to 30 minus 12 root 2, and all of that gives me 18 root 2. And that is my final answer. Okay, have a go at these 3 questions. If you're going to answer them, pause the video from now, because I will answer them right now. Okay, so question number 1. I have 4 root 5 plus 3 root 20. Obviously, we won't be able to add root 5 and root 20 as they're different variables. So we'd have to break down and simplify each surd. Root 5 can't be broken down any further because there is no square number that multiplies to give me root 5. So we just chuck it down and leave it root 5 as it is. So I have 4 root 5 plus. Then I have root 20. Root 20 can be broken down into root 4 times root 5, and that gives me 2 root 5. However, we can't forget the 3, so 3 times 2 root 5. And what this basically equals to is 4 root 5 plus 6 root 5. Therefore, my final answer is 4 plus 6 root 5, which is equal to 10 root 5. And that is my final answer. Question number 2. 7 root 2 minus 5 root 8 plus root 18. Okay, so we have 3 different variables over here, and we'd have to simplify each one to give me the same variable. So root 2 can't be broken down any further as I don't have a single square number that gives me, or that multiplies to give root 2. So we just chuck it down and leave it as it is. So I have 7 root 2 minus 5 root 8. Root 8 can be simplified into root 4 times root 2. So I'd have 2 root 2, and then we can't forget the 5. So 5 times 2 root 2. And then plus root 18 can be simplified into root 9 times root 2, which gives me 3 root 2. So in the end, I have 7 root 2 minus 5 times 2 root 2, which gives me 10 root 2, plus 3 root 2. This just means 7 minus 10 plus 3 root 2. This gives me, so 7 minus 10 is minus 3, and then minus 3 plus 3 gives me 0. Now, a common mistake people do is, since they assume the outside number is 0, then my answer is just root 2. No, that is wrong. Root 2 is basically 1 root 2. So if there's a 0, it's like trying to say it's 0x. Our answer is always going to be 0. Therefore, 7 minus 10 plus 3 root 2 gives me 0, and that is my final answer. So, question number 3. I have 6 root 3 plus 2 root 12 minus 5 root 27. So we'd have to simplify each surd. So, root 3, again, we can't simplify root 3 any further because we don't have a single square number that multiplies to give me root 3. So we just chuck it down, 6 root 3 plus 2 root 12. 12 root 12 I can simplify to give me root 4 times root 3. So that turns into 2 root 3. And then we chuck down the 2 over here. So it's 2 times 2 root 3. And then I have minus 5 root 27. Root 27 can be broken down into root 9 times root 3. And that gives me 3 root 3. And then we chuck down the 5. So I have 5 times 3 root 3. And then all of this gives me 6 root 3 plus 4 root 3 minus 15 root 3. And what this basically means is just 6 plus 4 minus 15 root 3. So 6 plus 4 is 10, and 10 minus 15 is minus 5. Therefore, my final answer is minus 5 root 3. Now we are done with adding and subtracting surds. Okay, so rationalizing surds. Rationalizing surds is the removal of the square root from the denominator in fractions. So if you don't know what a denominator is, just as a recap, if I have 1 over 4, this 4 over here is my denominator as it is the number at the bottom. Now the reason we do this is that examiners tend to just not like surds at the bottom of fractions. So there are 2 cases when we're rationalizing surds. We'll start off easy. The first one is when the surd is alone in the denominator. What this means is, for example, if I have 1 over root 3, the surd over here is alone and it's not being added or subtracted with anything else. So, how can I change this fraction where the denominator is not a square root, in this case root 3? The way to rationalize surds, we would have to multiply it by another fraction where this root 3 goes on both sides. So it goes on both the denominator and the numerator. So I have 1 over root 3 times root 3 over root 3. This gives me 1 times root 3, which is just 1 root 3, or you can just write it as root 3. We'll just write it as root 3 to make it look more simple. And then root 3 times root 3 is just 3. As covered in my previous video, if I have, for example, root y times root y, it just gives me y. To take it from a logical perspective, root 3 times root 3 is root 9, and root 9 is just equal to 3. So therefore, my rationalized answer for 1 over root 3 is root 3 over 3. I'll do another example. So here's another example, 15 over root 5. So how can I change this so that the root number is in the denominator? Again, we would have to multiply by another fraction, where this surd over here goes both at the bottom and the top of the fraction. So I have root 5 over root 5. So now I have 15 times root 5. That just gives me 15 root 5. And then root 5 times root 5 just gives me root 25, which is just 5. Now, to simplify this even further, we can actually simplify this 15 over here by this 5. So 15 divided by 5 gives me 3. And therefore, my final answer is 3 root 5. Now, if I have something such as 5 over 2 root 3. So, how do we do this? What's different about this is we have a number being multiplied by the surd. So, to do this, for now, we would just scribble off the 2 and save it for later. We just treat it as if it's only 5 over root 3. So the way to rationalize this is we'd multiply it by the surd being both at the bottom and the top. So times root 3 over root 3. And that gives me 5 times root 3, which gives me 5 root 3. And then root 3 times root 3, which just gives me 3. And then is where the 2 is revived. So the 2 would be multiplied by this 3 over here, because 2 root 3 means 2 times root 3. Once we've rationalized these 2 root 3's, we would have to times it by 2. So 3 times 2 gives me 6, and therefore my final answer is just 5 root 3 over 6. So case number 2, when the surd is in an expression. So we learned on the previous case that if I have 1 over root 3, this root 3 is an alone surd. It's not being added or subtracted by any number. When it's in an expression, that means it's being added or subtracted by a number. So for example, 1 over root 5 plus 2. So how do I rationalize this one? The way to rationalize it is we would have to conjugate this root 5 plus 2. What this basically means is, so same thing when the surd is alone. We'd multiply the top and bottom by root 5 plus 2, except we would have to conjugate it, which means we would have to invert this plus. We would have to change it. So the opposite of a plus is minus. So it would turn, instead of root 5 plus 2, it would turn into root 5 minus 2. And then at the bottom as well, root 5 minus 2. So the top, 1 times root 5 minus 2, just gives me root 5 minus 2. And then the denominator. Now, root 5 plus 2 times root 5 minus 2 is a case of double brackets, where it is formatted like this. If you do not know how to do double brackets, to just make it quick, all we have to do is this first root 5, we'd multiply it by this root 5 and this minus 2, and then this plus 2, we'd multiply it by this root 5 and this minus 2. So this root 5 times this root 5 gives me 5, or root 25. And then I have this root 5 times this minus 2 gives me minus 2 root 5. Then I have plus 2 times root 5 gives me plus 2 root 5. And then finally I have plus 2 times minus 2, which gives me minus 4. And then all we have to do is just simplify it. So I have minus 2 root 5 plus 2 root 5, that gives me 0. And then I have 5 minus 4, which gives me 1. So now we have our answer as 1. And then root 5 minus 2 over 1 is just equal to root 5 minus 2. And that is my final answer. So let's do another one, such as 4 over 7 minus root 5. So same thing here, we'd have to multiply the top and bottom by the conjugated version of this sign over here. So the opposite of minus would give me plus. So it would be times 7 plus root 5 over 7 plus root 5. So 4 times 7 plus root 5 gives me 4 times 7, which is 28, times 4 times root 5, which gives me plus 4 root 5. So at the top I have 28 plus 4 root 5. And then to multiply the denominators, again, this would be a case of double brackets. So I have 7 minus root 5 multiplied by 7 plus root 5. And we'd have to just do double brackets. So 7 times 7 gives me 49. Minus root 5, 7 times plus root 5 gives me plus 7 root 5. Minus root 5 times 7 gives me minus root 5. And then minus root 5 times plus root 5 gives me minus 5. So plus 7 root 5 minus 7 root 5 gives me 0. And then 49 minus 5 gives me 49 minus 5 gives me 44. So at the bottom, we'd have 44, and that is my final answer. Now, one more thing, to simplify this even further, we can divide 28, 4, and 44 by 4 as the lowest common multiple of each, the highest common factor of each is 4. So we would have 28 divided by 4 gives me 7, and then 4 divided by 4 is 1, so we'd ignore that and we just chuck in the root 5. So 7 plus root 5 over 44 divided by 4 is 11, so I have 7 plus root 5 over 11 being the most simplified version after we rationalize the surd. Okay, now it's your turn. Have a go at these 3 questions about rationalizing surds. If you're going to answer them, pause the video from now as I will answer them right now. Okay, question number 1. 2 over root 5. Nice and simple, we would just have to multiply them both by root 5. So no conjugating as the surd is alone. So 2 times root 5 gives me 2 root 5. And then root 5 times root 5 gives me 5, and that is my final answer. Question number 2, 3 over root 2 plus 1. So we would have to multiply it by another fraction where the top and bottom is the conjugated version of the surd. So all we have to do is invert the plus into a minus. So I have root 2 minus 1 and root 2 minus 1. So 3 times root 2 minus 1 gives me 3 root 2 minus 3. And then root 2 plus 1 times root 2 minus 1. This is a case of double brackets. So let me just do it over here. Root 2 plus 1, root 2 minus 1. So root 2 times root 2 gives me 2. Root 2 times minus 1 gives me minus root 2. Plus 1 times root 2 gives me plus root 2. And then finally I have plus 1 times minus 1, which gives me minus 1. And all of that just gives me 2 minus 1, which is equal to 1. So therefore my denominator is 1. And that is my final answer. 3 root 2 minus 3 over 1. And to just simplify even further, you can just remove the bracket and just write it as 3 root 2 minus 3. Okay, question 3, 4 over 3 minus root 7. So again, multiply them all with the conjugated version of the denominator. So we'd have to invert the minus into a plus. So times 3 plus root 7 over 3 plus root 7. And then I have, at the top, I have 4 times 3, which is 12, plus 4 times root 7 gives me 4 root 7. Then I have a case of double brackets, so 3 minus root 7 times 3 plus root 7. So 3 times 3 is 9. 3 times root 7 is plus 3 root 7. Then I have minus root 7 times 3 gives me minus 3 root 7. And then I have minus root 7 times plus root 7, which just gives me minus 7. So all of this is just equal to 9 minus 7, which gives me 2. And now I can divide this 12 and this 4 by 2. So 12 divided by 2 is 6, and 4 divided by 2 is 4. Therefore, my final answer is 6 plus 2 root 7. And now we've officially finished the entirety of surds. I hope I've explained it to you in the most understandable way possible, and I hope now that you've fully understood this topic. This is going to be the end of the video. Have a good day, and goodbye.